Many events that occurs in the Earth's atmosphere are incredibly amazing. And one of these are these dancing lights that you can see in my background. These curtains of lights are only visible in the North and South Pole. According to NASA, or the National Aeronautics and Space Administration, it was in 1619 when Galileo Galilei coined the term Aurora Borealis. Aurora was named after the goddess of the dawn according to the Romans mythology, and Borealis came from the term Boreas after the Greek god of the north wind. The aurora in the South Pole is called the Southern Light or Aurora Australis. Auroras are usually green in color but are sometimes blue, violet, pink, or even red. To know more on how this magical weather event was formed, why these lights are only seen in the North and South Pole, and what causes these colors of dancing lights, there are three main points that we need to understand. First, the objects released by the Sun's magnetic field. Second, the Earth's magnetic field. And lastly, how those objects from the Sun arrived and interacts with the Earth's atmosphere. Sun, like the Earth and most of the planet, has magnetic field. According to spaceplace.nasa.gov, Sun runs through a cycle of 22 years called solar cycle. Every 11 years, it reverses its magnetic poles. This means that the Sun's north and south pole switch places, and it takes another 11 years for it to flip back again. During the cycle, the Sun burns with so much energy and heat gases around it. This causes giant eruption in the Sun, and these eruptions sends powerful bursts of energy and material into the space, known as solar winds. These solar winds are mainly charged electrons and protons. So now, let us discuss the Earth's magnetic field. Earth is a giant magnet. According to nasa.gov, it is surrounded by a giant bubble called the magnetosphere that shields our home planet from solar and cosmic particles and from the constant flow of solar wind that is streaming off the Sun. As solar wind reaches the Earth, the magnetosphere deflects it. However, some manage to get through towards the pole where the magnetic field is weaker. From there, charged particles carried by the solar winds enters the Earth's atmosphere. In the ionosphere, part of the Earth's atmosphere, ions or the charged particles of solar winds collide with gas particles in the Earth's atmosphere, mainly the nitrogen and oxygen atoms. Movements of these particles also causes electricity, which excites the molecules in the Earth's atmosphere. This energy serves to move the electrons of the nitrogen and oxygen atoms from their ground state to an excited state, and comes back once again to their ground state by emitting packets of light known as photons. This process creates the aurora. The different colors of aurora are due to the type of gas particles colliding with the electrons and protons carried by the solar wind. It is also affected by its altitude. Typically, when particles collide with oxygen, yellow and green colors are produced. Interaction with nitrogen produces red, violet, and occasionally blue. As to its altitude, always remember the rule which states that the density decreases as height or altitude increases. This means that the color of Aurora Borealis depends on the density of the nitrogen and oxygen atoms and the height where charged particles and atoms collide. Red colors of light appear in the higher altitude where oxygen are less concentrated, and green colors, which are commonly seen, appears in the lower latitude. There are still lots of wonderful events or phenomena around us. Through science or scientific researches, mysteries behind it could be unraveled.